Hello everyone, I hope you all are doing really well. Sabani this side. In this video, I'm going to talk about sidecar containers. So sidecar container is a design pattern in Kubernetes where you run additional containers alongside your main application container in the same pod. These kind of containers are called sidecars because they are attached to your main application. They're sharing the life cycle, providing additional support and functionalities for you without being part of the core business logic. So the key characteristics of a sidecar containers, if I talk about, is co-location and the shared lifecycle. So they are located within the same pod. They share the lifecycle of the same pod, right? However, logically you are splitting the business core functionalities in your application main pod, whereas you are kind of offloading any additional configurations to these types of containers. Shared resources is another key feature. So it utilizes this network namespace. They communicate with your application pod using localhost and shared nodes. And they also share storage volume. So you can easily create a volume and mount it on top of both your application container as well as your sidecar container. However, though you are sharing this, there are separation of concerns, right? So if I talk about the common use cases of using a sidecar container, so it typically involves the main use cases are the logging and monitoring purpose. So you can use logging agents like Fluentd or metrics collecting agent called Prometheus. So your app container is going to dump logs or metrics in a specific location, or in some way it's going to communicate with the sidecar container to ship metrics. In that case, sidecar containers would accept that or read it from a volume if it's in case of a log, and it takes the responsibility of shipping it to a different storage location. So it could be in S3, it could be any different storage facilities. Additionally, another use case is service mesh proxying. So in a microservice based environment, service to service communication plays a critical role. So that is achieved with the help of service mesh. So it could be easily utilized using you can use Envoy proxy or Istio, Linkerd, etc. For security authentication purpose as well, you can utilize these sidecars containers for configuration sync as well, like watching a configuration source like config map or a vault for changes, and updating the configuration file to a shared volume, which would be again consumed by your main application. For data synchronization, so if a process to sync secrets and certificates to a shared volume, if that is needed, sidecar containers comes really handy in those cases. How is it different in compared to init containers? So if you remember, I talked about init containers earlier in my previous video. So init containers basically performs a one-time setup or initialization before your application container starts, and they run to the completion and then exits before your main application is going to start. However, in case of sidecar containers, things are different. So they provide continuous support functionalities during the entire life cycle of your application container and the pod, and it runs concurrently with the main container for the entire pod's life. So that is all about the feature. Now let's start with a demo. So if I show you here in the documentation itself, so you will find an example over here, like how sidecar containers are used in Kubernetes. You will find that in this template there are three sections under the pod spec file, right? So it is creating a deployment with a pod count replica equal to 1, and the main application container that it's talking about is my app, which is using an Alpine latest image. Better let me show you over here. And what it is doing is, so it has a container, it has the init container, it has the volume. So volume is a common common volume that I am using, which would be utilized by both this container and init container. So you might be wondering like how we're talking about sidecars, but we are specifying init container. So what's the difference? How we mention that this container is going to act as like init sidecar container. So the main important key over here is the restart policy. So you need to specify the restart policy as always. So in case this init containers go exit, it sometimes gets terminated, it's going to get restart. And what it is doing is the main application, it is generating some logs and storing it in the opt logs.txt file. And it's sleeping for 1 second. At an interval of 1 second, it's writing this echo logging. And what's the job of this log shipper? So this Alpine test image, what it is doing, it's simply performing a tail operation. This is just to give you a flavor of how Sidecar works, but there can be underlying configurations within the base image that you're using that would perform the shipping logic, like the logs that are generated by the main. So that comes under the logging use case specifically. So let's try to create and see how it works. kubectl create -f and followed by the file name. It got created, and let's see kubectl get pods. So if I show you this, kubectl describe pod followed by this. So you see over here, so there are init container part as well under the description. If I show you, this is the command it's going to run, and you see the continuous running state, and it started at this point. And here is your main application, which is already running. Okay, and this is the volume. And if I proceed with checking the logs, kubectl, this is my pod name, so it's going to be log-f, and followed by I need to give a container name. So if I want to check my main application container log, so I will just add this name, kubectl, I'm sorry, so I have to give logs. So you see continuously this echo statement is getting print over here, and it's also continuously writing it to the logs.txt. And if I go over here and just try to write log shipper, and over here it's continuously writing to this specific file, and this same file is again mounted to both these containers, your application container and init container under shared. It's a shared volume that is in this directory that is getting mounted over here. So this is how it's done. This is how you can actually utilize a sidecar container. Not only that, that you can use a sidecar container along with a Kubernetes job as well. Kubernetes job is another kind of object where you can, in case you want to run a code at a certain point of time, you can utilize job, like one-time approach. Like if you want to use, then definitely jobs would solve the purpose, and you can run additional init containers like sidecar containers along with a job as well. So that is all for now. I hope you really like the video, and let me know if you have any questions in the comment section. Stay tuned to my channel, more videos are going to come. Thank you.